Some river landforms are created as a result of erosion, deposition, or both. Some examples of fluvial erosion are as follows. Waterfalls occur when there is a sudden change in the gradient of a river as it flows downstream. They form when a band of hard rock meets softer rock. The softer rock erodes much faster than the harder rock, causing a step in the riverbed. The step causes the water to speed up due to a lack of friction, giving it greater erosive power. The soft rock is eroded further, and the harder rock experiences undercutting. The hard rock can then collapse. A plunge pool at the base of the waterfall is created by the abrasion of rock fragments, which have collapsed from above. Eventually, more undercutting causes more collapse, making the waterfall retreat to leave a steep, sided gorge. Rapids are essentially mini waterfalls. They're made with a combination of turbulent water and steep sections of hard rock. The water flows over the rock, eventually causing the rapids to become steeper and steeper as softer rock erodes away. This can create white water. Potholes can form when water meets bedload and it's forced to flow over it. The water then downcuts behind the bedload, and water turbulence moves in a circular motion called eddy currents, which erodes the riverbed and creates cylindrical holes. Pebbles can become trapped in these depressions and carry out further abrasion. As a result, the circular hollows become deeper and wider. The following landforms are created by a combination of erosion and deposition. Meanders occur in the middle and lower sections of a river. These curvy features are made due to an alternating deep sections of the river, called pools, and shallower sections called riffles. Pools are more efficient, with greater energy and therefore greater erosive power, all because they're deep, whereas energy is lost as a river flows over a shallow riffle due to friction. The flow of a river becomes irregular, and the maximum flow is directed toward one side of the riverbank. This results in erosion and undercutting on that side, and deposition occurs on the other. On the outside bend, the river channel is very deep and concave, since this is where the water with the most energy flows, and loss of erosion by hydraulic action and corrosion takes place. Lateral erosion causes river cliffs to form on the outside bend. The flow of the river is much slower on the inside bend, so deposition forms a slip-off slope, composed of sand or shingle. Oxbow lakes are horseshoe-shaped lakes separated from an adjacent river. They are the evolution of meanders that undergo extensive deposition and erosion. As we already know with meanders, strong erosion takes place on the outside bend and deposition takes place on the inside. Eventually, the meander neck begins to narrow. In times of high discharge, such as a flood, it's more efficient for a river to flow through the neck of a meander than around it, and when discharge levels resume to normal, the water continues to follow this course. The connected meander is now a cutoff. Deposition eventually separates the cutoff from the main channel, leaving behind an oxbow lake. The water becomes stagnant, and in time the lake gradually slits up, becoming a crescent-shaped stretch of marsh, called a meander scar. And finally, these river landforms are created by fluvial deposition. Braiding occurs when rivers are carrying a large amount of eroded sediment, such as sand and gravel. If the river has varying discharges, or the velocity drops, or the sediment load is far too heavy for the river to carry, the sediment is deposited. The river is then divided into small channels, separated by small islands called eyots. The channels eventually rejoin to form a single channel. Floodplains are large, flat areas of land located on either side of a river, where the water floods when a high discharge is experienced. When a river floods, an increase in friction causes the efficiency to decrease, so any load being carried is deposited. Levees are natural, raised embankments formed as a river overflows its banks. Again, the increase in friction and reduction in efficiency means that sediment is deposited. The largest and heaviest load is dropped first. Finer material is deposited further away from the banks. Levees gradually increase the height of a river, decreasing the likelihood of flooding. Deltas are located at the mouth of a river as it enters the lake or sea. The velocity and sediment carrying capacity of the river decreases upon entering the sea or lake, and bedload is deposited. Deltas only form when the rate of deposition exceeds the rate of sediment removal. Flocculation occurs as fresh water mixes with seawater and clay particles coagulate due to the chemical reaction. These clay particles sink due to their increased weight. Deltas are composed of 3 sediment beds. The bottom set bed is composed mainly of clay, by flocculation, and some other fine-grained sediments. This bed reaches a far distance from the river mouth, since fine sediment can be transported a reasonable distance. The foreset bed is composed of coarser, medium-sized sediment that does not travel very far into the stationary body of water, and the topset bed is composed of larger and heavier particles. The 3 primary delta shapes are the cuspit delta, the arcuate delta, and the bird's foot delta. Cuspit deltas are shaped like a curved V, and they are formed by gentle but opposing sea currents, which spread the sediment out. An example of this would be the Ebro Delta in Spain. Arcuate deltas have a curved shoreline, which forms when a river meets a sea with alternating current directions. An example of this would be the Nile Delta in Egypt. A bird's foot delta contains fingers of deposition that build out into the sea. These extend reasonably far into the water and form when the river's current is stronger than the sea's waves. An example of this would be the Mississippi Delta. And that's it. Thanks for watching.